Is that everything? Yeah, everything's showing up right on OBS. Okay, so long time no see. When was the last time I streamed? It was back in the first Face Connect game jam. Let me turn my microphone down a touch. There we go. How about now? Still going to the red. Still going to the red. Still going to the red. Still going... Okay, that's it. So last time I streamed was the first Face Connect game jam. Now since that has happened, quite a few stuff has happened. For one reason or another, I haven't been able to stream. A second Face Connect game jam has been and went. I tried to make a expansion of my previous entry, but unfortunately I bit off more than I can chew. You know, that's just how things go sometimes. So, if you haven't read the news, Unity have just done something extremely stupid. Like, I can't find the words as to how really dumb this thing's. CliffsNotes version is that they decided to charge per install from the buyer. So any free-to-play game, any free game, any demo, what have you, that's been made in Unity, yeah, the studio is going to be charged per install. I think it's something like 20 cents or something along those lines. So I had a decision to make. Obviously, I'm still not at the level where I can professionally make games and release them for money. Got a few ideas in the head, but you know, it's getting them actually encoded is another thing entirely. Also, they they removed the personal tier of pricing. So if I recall correctly, this personal tier was something like 20, 30, 40 bucks a year. And yeah, it gave you some features, most of which was allowing you to remove the Unity logo from the splash screen, which if you've played a few games, you'd know that the Unity logo has this sort of stigma around it with these as it being a sort of an asset flip or a rather low quality effort. So that was the main reason I bought a personal thing, and unfortunately they've removed that. So the next cheapest tier is something like 8-10 times that much. So yeah, talking like $200 a year range. I don't know the exact figure. So yeah, that's a bummer and all, and basically there's been a mass exodus pretty much overnight. My mic is still being a bit of a prick. How about now? Sorry about that. Yeah, okay, it's staying in the orange mode, so forget about that. So yeah, there's been a massive exodus. People have made sites overnight as to whether they want to go from Unity to Godot or Unreal Engine. Over the past few hours, over the past day, we should say, I've done a bit of research into both engines. I have both installed. I've had a slight play around on each. Although the main thing that tipped it in the direction of Godot engine is basically Godot stuff can be played in the browser, whilst Unreal Engine it used to, but that's been deprecated. Plus, I'm led to believe that GD script is a lot like Python. Of course, I do know Python. I also know C++, but I wouldn't say I'm quote-unquote fluent in any ways. So, plan for today is that I'll be streaming this part 1, if you want to call it that, for until about, I'm going to say about 7:30, so give it about a couple hours, some change. Then I need to run some errands, and then after that, I'll go and pick it up again, part 2, which I'll go until I'm tired, I suppose. So, I'm going to be following this tutorial here. Now, I've done the official Godot tutorial, your first 2D game and your first 3D game. Basically, it made you, it it had you program this sort of half bullet hell, half vampire survivors clone, except not really because you're not shooting anything. Basically a dodge 'em up, if you want to call it that. So yeah, I've gone through that. I know a very little bit about Godot engine, but what I'm going to do is instead of just chuck myself in at the deep end and try and remake Taco Tidy in Godot, instead I'm going to follow this tutorial here by Christine Koemans. Please don't come for my kneecaps. And yeah, I'm just going to go through her tutorial and see where we go, see how far we get. So, I'm going to read along this whole article, and then when it says do stuff, then I'll switch to here. Man, I love advanced scene switcher. Yeah, switch here and back. When was this? So, have you ever wondered what made Arthur Morgan from Red Dead Redemption so iconic? For me, it's the nostalgic feeling that arises when I get to play in an era that I would never be able to experience in real time. It's the magic of fantasy, and that's what brought me to create the rootinest, tootinest 2D RPG game tutorial series out there, made with none other than Godot 4 and GD Script. This tutorial series aims to teach you how to make a game from start to finish, and will ultimately show you all the things that you need to know as a beginner. Before we continue, I have to give credit where credit is due. Not me, Christine, but you understand, come on. Because this Dusty Trails game dev series was inspired by David Depeche's Godot 3.0 simple RPG series from 2018, which has now been deprecated and removed. But by now you may be asking, okay, so what exactly is this game we'll be creating about? Well, Dusty Trails is a Western-esque Wild West RPG in which you can run around a full map while shooting and looting enemies and completing quests, and they've put a little preview video here. This, I'm guessing, is going to be a gameplay video. I'm gonna up the speed a bit. So it looks like Stardew Valley at first glance. Yeah, talking to people, A, B, pickups. Yep, oh, here's the combat. We've got these cacti pistoleros. Oh, okay. So I'm guessing it's more like Zelda. Well, no, not Zelda, because Zelda you slash dudes and here you shoot them. Whatever. It's a top-down shooter. Yeah, that's pretty much it. I'm guessing, yeah, it's gonna be all these. It's gonna be all, what you call it? Rooting, tooting, and shooting, I suppose. In that order. Anyways, this tutorial series will cover the following aspects: player animations, movements and statistics, complete game GUI, inventory pickups and consumables, enemy movements, animations and stats, blah. Enemy random roaming and spawning, random loot drops, plenemy, what? Player and enemy death, damage and attacks, XP and leveling, basic customizable NPC with a quest, scene transitions, game music and sound effects, game saving, pausing and loading, game map with collisions and camera, and a bonus as a simple shopkeeper, and project exporting. Please note that this tutorial is meant for gears, so if you're an advanced player in the game of Godot 4, this tutorial was not for you, which I'm not. This tutorial uses Godot version 4.0.3, so I was going to use since concentrated. So I'm using, from what I recall, is there an about? Is there an, here we go, here an about Godot. So I'm using version 4.1.1, so there might be a bit of niggling. Well, we'll get there when we get there. So what we're going to learn in this part is how to navigate through the Godot editor, How to change your project settings, as well as work with node properties, how to create scenes, how to add nodes to scenes, and that's it, of course. Editor overview. Before we go begin coding and going crazy. Okay, fine, that's the best part, but whatever. We first need to understand the layout of the Godot editor. So if you're already acquainted with the editor, you can skip to the project setup of this part. I kind of know where everything is, but might as well have a refresher. Haven't installed Godot yet. I have. I've plonked it on Steam. Once it's done, it doesn't require any installation. You launch the executable, you'll admit the project manager window. Asset library projects, those are the demo stuff. Where else? Ah, here we go. Click new project, Windows Deployment. You can choose our project save location and go to maintenance of dust trials and go ahead whatever you want. Free rendering menu is forward mode, which is for desktop console stuff, mobile mode, self-explanatory, and compatibility mode if you're running a toaster, I suppose. Graphics card is compatibility with the Vulkan version supported by Godot 4 because you need to choose compatibility mode. New rendering updates here, and it gives a link. I suppose if it starts rendering like arse on my end, I'll probably switch. Yeah, you can easily enough switch from there. So it's not like Unity where you have to install the whole URP package and then put in all these bloody files. And it's so bloody convoluted you might as well start a new project and then plonk everything over rather than plonk the URP. Anyway, no Unity. Okay. Select create and edit will transfer to our project window. On top of our workspace where we complete our tasks. 3D will always be active by default if you can click on the options. So yes, unlike Unity, you have separate workspaces for 2D and 3D rather than this little toggle here. You also have something else for a separate thing for scripting, and you have this asset lib, which is, I'm guessing, is an asset store. Well, I say store, but I'm led to believe everything's free. Okay, where are we? 2D workspace is used to edit and view 2D scenes for 2D games. 3D scenes. Script workspace is the code editor. Asset lib, oh yeah, we've been over that. Godot workspace Sorry, I need to click in the windows to show it rather than look at my eyes. So left click select, right click adds a node, like that. Middle click pans and moves it, and wheeling zooms in and out. I don't know if you can see the axes lines on your screen, but there it is. Panel on the left side is the scene doc, which is this thing here. This lists the content of the current scene that you have open, and you can also add new nodes that you're seeing in this doc. Scene in Godot is blah blah blah. Oh, sorry. Yeah, a scene in Godot is the main holder or container for nodes, and nodes are the main building blocks in the game. So a scene in Godot is not a scene in Unity. Just to make it very clear. Different nodes have different functions. For example, collision shapes and animation sprites each have their purpose. So I'm guessing these collision shapes will be 2D colliders, animation sprites, self-explanatory. Having the ability to combine them in a single scene allows us to create components for our game with more complex functions. So scenes are kind of game objects, I suppose? I mean, yeah, well, I think they're game objects from the tutorials I've already done, but someone can probably correct me. Hang on a minute. Where are we? Yeah. Oh yeah. Scenes can also instantiate other scenes. Instantiate, yes, they probably are game objects. Having the ability to combine them in a single scene can create components for our game more complete. Blah 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 blah. Godot documentation on nodes and scenes. Okay. And we've got a diagram of the level scene, and that contains all this UI, audio, tile map, player scenes, enemy scenes. Okay. Is it saying which is a node? Ah, oh, okay. Player scene, skeleton, and that's the node, and then these. So I'm guessing every square thing here is a node. Okay. Other panel's called the import dock. This thing here, so you've got these tabs at the top. This is where you can set or edit projects of assets such as images, fonts, audio files, blah blah blah. Yeah. Below the scene and import dock, you'll find the file system panel, which is where you'll manage your project files, folders, assets. You can drag new assets into the file to more than blah 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 blah. So that's it empty and that's it full. Panel on the right side of the window is called the inspector. Same as in Unity, I suppose. Node panel next to it is where you can hook up signals and add groups to them. To nodes. Okay, this is new. Groups can be used to group types of scenes or nodes together. So for example, our NPCs so like layers. I get it. Signals can be used in many cases to notify that the game has the so these signals, I'm guessing, are like C# events. Okay, so notify the game that this allows us to then tell the game what to do when certain events have occurred. Most nodes have built-in signals such as buttons and animations. Also creates custom signals. Blah blah. Okay, so it's a sort of a visual scripting flowchart. Is this player health? Yeah, it's just normal flowchart, I suppose. Play button, is it pressed? On button press signal. Boop. Start the game. Okay. Above the inspector and node dock, you'll see the options which you use to play, pause, restart. They're here, right at the top right of your screen. This is where we'll launch the launch the game to test it. At the bottom of the window, there's the output panel, debugger, audio mixer, search results, animations, shaders. Collapse by default to save screen space, but if you click on them, they will maximize. Certain nodes that are customizable, such as the tile map or animation player node, will add new options to this window. Oh, okay. So it's this little thing at the bottom here. That's what they mean by collapsed. Output will return printed messages or notifications that we add to the code for testing. The debugger, okay, so it's built in rather than having to go through Visual Studio. Audio mixer is used to edit audio. Oh, okay, okay. This is new. So we don't have to do it in Audacity and then import and then try it again and then obviously and then it doesn't work and then we can do it to Audacity again and blah blah blah. No, I can do it all in Engine. Nice. Animation editor used to create animations for the animation player node. We'll come to that in a bit. In the ribbon or menu bar above, which is blocked by the clock on your stream, on the stream window. Here you can manage your scenes underneath the scenes tab. Can be added, saved, opened, or closed. You can manage your project settings and properties underneath the projects tab. Scene project, yes. Open your project manager window. You can enable or disable debugging tools in debug. We want to say make collisions visible so you can see if collision events are executed. Oh, okay, okay. That's new. That I see being very, very helpful. The editor tab allows you to change settings related to the editor. Lastly, the help tab gives you links to the docs. Before I start a project, I generally make a list of steps or checklists you need to take to make a game. Generally just an outline and make different amendments as I go about actually making it. So it's not supposed to be a linear journey, obviously. Everyone goes about this differently, but if you're interested in what Mr. Shoes look like, you view the example. Okay, so he sets it up. And then he has... Okay. You will be challenged to create second person. Okay. Set up project, set up player character. So I'm guessing that's what we'll be doing. Oh, changing side screen width and height. Okay. I'm using this color palette, colorhex.com, that I found online for the game, just in case you're more wondering where they got the color scheme values from. Okay. So the full source code can be found in the GitHub, because don't bother reading, because I'll leave the separate source code versions at the end of each part, that way you won't get confused by reading code. Set asset new reaction can be downloaded here, drivegoogle.com. Credits for free assets can be found on GitHub, once you download it, okay. So... if you'll bear with me a touch, whilst I get all this sorted out. Let me just fiddle about with OBS. Hang on. Okay. Right, let me dig into the file system and I'll be right with you. And we're back, I think. Okay. Yeah, it's been a bit of a slowdown whilst I was plonking everything in. But yeah, next thing you know, don't put in a, I don't know, drag stuff out of a zip file because it just takes forever. Just unzip it first and then do that. Anyways, so where are we? Once we've downloaded the assets, we can extract the file and drag it into my file system panel. Then we can go ahead, delete the default icon.svg and readme.markdown files that are present in the project. I don't see a readme.markdown. Probably got removed in 4.1. I don't know. Right click on the panel and let's create three new folders: scenes, GUI, and scripts. As you command. Scripts. The scenes folder will contain all of our .tscn files, player scene, NPC scene. Oh, so TSCN is just scene. Scene. Don't know what the T stands for, but whatever. Template? I don't know. Scripts folder will contain all of our GD script files, and the GUI folder will contain all of our UI element scenes. I have not talked this much in bloody yonks, I will say that much. In the scenes folder, let's create our first scene, which will be our main scene. Main scene is the scene that will serve as the core container for our game element. It's the default scene equivalent, I suppose. Yeah, well, we add our map, characters, and items to the main scene. You add a scene, you can right click on the file system panel and add it like grid of folders, or you can click this plus icon in the scene dock. This thing here. Where am I? This is the quicker way, so we'll do it this way from here out, yep. You'll see that it prompts you to select a node. The node you choose will be the root or the parent node. The root node is the highest node in the tree structure and has no parent. We can always change this node later on, so don't try to choose the wrong one. We need to select node 2D. This thing here. That's the root node. The space node through a 2D game. You usually use the main scene. You can also choose. Excuse me. Automatically choose this node to be your root node in the scene.2D scene option. You'll now see that a 2D node, a node 2D node, try saying that 2 times fast, has been added to our root, but our scene hasn't been saved yet. Save it in the scenes menu using the control shortcut. So use the shortcut control S. Save the. Oh, I was about to show my entire file system there. Save the scene as main in the scenes folder. Main, capital M. And as it would show, it's in here. Now I can double click on the node 2D root node. Node 2D root node, node 2D root node. Yeah, I'm hopeless. I'm hopeless with that sort of thing. Let's rename it to match our scene name of our scene for simplicity. Main. Now we can add child nodes to our child nodes to our root node. You can do this via the plus icon again. Well, we're making a 2D game, not a 3D game, so the 3D node will not. Let's add a sprite 2D node. For now, because I want to show you something. Take note that any node you add will be added to your recent panel in the node menu, so you can easily select them there next time around. Don't search for it. It's just Sprite 2D. In the 2D space workspace, because we're making a 2D game, select your Sprite 2D node and press F to pay respects. Sorry, focus on the selected node. With your node selected in the inspector panel, you'll see the option for texture. This is our sprite's image. I know for a fact that I'm going to be pressing numpad dot because that's how it works in Blender to focus. I know I'm going to be making that mistake. Blah blah blah, blah. Focus inspector panel, you'll see the option for texture. This is our sprite's image. If you go into your assets folder, you can drag any image you want into that texture property. Any image you want. So if you go to your assets folder, yeah. I'm guessing we have player angle. What's that? Hang on. They have player angle 1 sheet. We just drag and drop this to there. There we go. If you zoom in on your sprite, you'll notice that it's a bit blurry. Yeah, it's a bit blurry. This won't do, but luckily I have a fix for you. In your project setting, if project settings option, this thing here, change your textures rendering from linear to nearest. Textures rendering. So that is in rendering textures. Aha. From linear to nearest. Okay. Hang on, I've got a text. Hang on, let me field this and I'll be right back. Okay, there we go. Sorry about that. In your project settings option underneath projects, linear to nearest. Yes, we've done that, and everything's very crisp. Image assets are always high quality. You'll know nice and then nice and clear. Yep. The last thing we need to do for this part is set our main scene as well. Our main scene. Your project settings underneath. Project settings. Underneath application run. You can set your main scene here. Can I drag and drop? I cannot. But I can just go there, yep. Later on we will change it to be our menu scene because you want the player to agree with the starting menu, so just chucking them in the game. Congratulations, you've now learned how to navigate the Godot editor, as well as work with nodes and scenes, which are core fundamentals for your use throughout your game. It will be good practice for you to create your own GitHub repo for your project so you can make regular backups of it. Nope. Coding by the seat of our pants, boy. And that's it for our project overview and setup section. In the next part, we'll set up our game character, the player, more nodes. You'll get to scripts for the first time. Remember to save your game project, and I'll see you in the next part. Save scene. Save project. I'm guessing they mean by save all scenes. I don't know. Tutorial release. Attention, everyone! I haven't watched The American Office. I'm sorry. I don't know what this guy sounds like. Links to all parts. The short series has 23 chapters. Fucking me. That's probably why it was like 750 megs as a zip. We're releasing all the chapters in sectional daily parts over the next couple of weeks. You can find an updated list of tutorial links for all 23 parts in the series like here. If you like this series or want to skip the wait and access the offline full version of the tutorials, you can support me by buying the offline booklet for just $3 on Ko-Fi. I'll probably plonk this link into the description when I stop streaming. So, hang on. Just to preempt, just in case this link goes where I don't think it does, it goes to something called Gitbook. I think it's like GitHub, but I just want to make sure that it doesn't... Okay, maybe not. Yeah, I forgot to turn off Advanced Scene Switcher. Yeah, if that had shown me anything about my IP, yeah, I'd be right buggered. Sorry about that. Tutorial series has 25 chapters. I'll post all the chapters in sectional daily parts, which means we don't have to go through medium.com. Thank God. If you want to like the series or want to skip the wait and access the full offline version, 25 chapters, and I think it's concluded. You can support me by buying the offline booklet for just $4 on Ko-Fi. It was... That Medium page said free. Inflation for you, I suppose. So, we're on part 2. This Gitbook thing. It looks like it's handy. It looks very handy. Yeah, I'll have to make a note of this website if I ever want to make a book of some sort. Maybe an instruction manual? I don't know. Blah, 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 blah. Let's make a Godot 4 by learning an RPG. Let's make Godot 4 by learning an RPG. What the bloody hell are you talking about, Mr. Spirit? Anyways, part 2. Player setup and movement input. This site better not have a paywall on it. I'm just going to scroll to the bottom, hang on. No, it doesn't look like there's a paywall. Honestly, whatever. Welcome back to our Dusty Trails tutorial series. If you missed the previous part, you can find links to it at the end of this tutorial. Also, fuck off Medium tab. You can probably tell that I really do not like Medium.com. Yeah, okay. Nah, that's they gotta make their money somehow. You can't really blame them for that. Now that we have our project set up, we can now go on to creating our player scene. Our player scene will contain nodes and scripts that will allow us to see a character and control them so that we can run around and interact with the world. In our main scene, we can go ahead and delete that Sprite 2D node. Yes, good, it was getting in the way. Delete the node. Yes. Delete that Sprite 2D node that we added earlier. We can create a whole new scene for our player and then instantiate it in our main scene. Instancing allows us to replicate an object from a template that we can modify them separately. In other words, we will have our player separate from our main scene. We can treat it as a separate object. Blah, blah, blah. Basic object orientation. In your workspace, click the plus icon next to main to create a new one. Oh, so select a new tab. Oh, I get ya. In the scene dock, add a new root node, which needs to be a character body 2D. Sorry, hang on. Sorry, I just don't see my PNG just jumping about when I'm talking on the mic. Yeah, my mic is a bit finicky. It's a Toner TC3 something or other. At the risk of going on, Toner TC777. It's alright, I suppose. Better than a headset mic or a random potato mic. Yeah, okay. Yeah, this is the first time I'm working with these new equalizer settings on stream, so sometimes I find myself stealing a glance at the Mike Orcs gain bar, whatever the hell you call it, and see if it's still staying in the yellow bit. Anyways, yes, wanted to be a character body 2D. Whoa, hang on. Need this root node to be a character body. Okay. Yeah, that's one thing I've noticed. Oh, it's because I clicked this 2D scene, and it makes a node 2D, not a... It doesn't give you this thing. That's why. Needs it to be a character body 2D node, which is a specialized 2D physics body node for characters that can be moved via scripts. Okay. Double click the character body 2D node to rename it to player. Where are we? Hang on. We can also go ahead and save our new scene as player in our scenes folder. Hang on. Oh, okay. Rename to player, save as it, and then save the scene as player. Save scene, player. What's with the what are the capitalization conventions with regards to this? I mean, the tutorial is putting scenes as capitals, but it just seems to default to lowercase whenever I save it. Well, I suppose it's one of those whatever works for you kind of things. You'll notice that there's a warning icon next to your root node. That's what a warning icon looks like. If you hover over it, you'll see the warning message. You'll tease us that a character has no shape, so it cannot collide or interact with others. So yeah, it gives you a mouse over thing, and if you click it, it'll give you a dialog box. To fix this, we need to add a collision shape 2D node. This node will also return a warning message because we haven't assigned it a shape in the pixel panel yet. Let's fix this by clicking on the box next to the shape. Okay, so let's make the collision shape 2D node. That's going to have the warning line because there's no shape on it. So let's fix this by clicking on the box next to shape and selecting a shape. The type of shape that you choose, Roger, will depend on what you want them to accomplish and whether they need to collide towards their body shape. So a circular character might have a circle collision and so on. So we'll want a capsule shape, which is your bog standard thing for a... Press F to pay focus. So yeah, it's your bog standard player thingy. You'll now see that we have a collision shape that can collide with other bodies in the game, but we don't even have a body yet. To see our character, we need to assign it to a sprite. Now we can go about this via two ways: via the sprite 2D node and the animated sprite 2D node. Sprite 2D node is perfect for a static object, e.g. scenery. And an animated sprite 2D object, however, it's the opposite. We need to have an object that requires sprite sheets to be animated, i.e. players, non-player characters. Well, yeah, characters, I suppose. I suppose that's probably why it's called a character node 2D. Animated sprite, players, root node selected. Make sure you select it and not your collision tube shape 2D node. Because we're going to add a new, so player, thank you. Add an animated sprite 2D node, mated, that. Yep, animated sprite 2D node. Now we just want to right click and select change type. This node will once again return a warning, and that's because it has no sprite sheet assigned, so it can't return animation frames. Go to the inspector panel. Underneath, next to sprite frames, select new sprite frames. Oh, so it's like a sort of a blender thing. It creates a dummy object automatically. Okay. This sprite frames resource allows us to import image files or a folder containing said files and provide the animation frames for the sprite. To configure our sprite frames resource, click on it and you will see a new option pop up in our panel below. This thing here. It's in this panel where we can add new animations. Sorry, this panel here. It's showing that on the screen. Where we can add new animations, delete animations, play animations, or edit them. Default animation can be deleted or renamed. We will add all of our players' animations in the next part so we can then explore this node in more detail. For now, let's just assign a sprite to our default animation by clicking the Add Frames from Sprite Sheet option. Add frames from sprite sheet, this thing. The waffle button. Open a file. Hang on. Oh yeah, it'll take us to res. So we want to go to Assets, Player Angle 1 Sheet. Oh no, Player Front Sheet. This thing. Another window will pop up. This select frames window, and it's here we need to crop our individual sprites to make an animation. The default horizontal and vertical values are 4. However, horizontally we can count our player frames group to 14 to change the horizontal value to 14. And there we go, and yeah, we're bisecting the thing because we have 5. Vertically, we count our plane frames go to 5, so there we go. That's... Is there a zoom in? Ah, here we go. These buttons zoom in. I like that. I think, is this the hit animation? I like that. I like that surprise thing. Now we can set the frames we want in order to create one animation. This sheet has 5 possible animations: idle, walk, attack, damage, and death. For now, let's just select the second row to create a basic walk animation. Make sure to select it in order, otherwise you'll have to rearrange it in the spectral panel. 0, 1, 2, 7. Yep, that's in order. Add 8 frames. Okay. Ah, here we go. So if we play it, I would sing some like Big Iron, but I don't know the words. Sorry. Our default animation now has 8 frames added, blah 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 blah. Our player walks a bit slow, so let's go from 5 to 10 FPS. There we go. With our walk animation added, we can now add the inputs and functionality to move them around. Before we can jump the gun and start coding, we need to add an input action. This is the physical controls, such as our keyboard keys, joysticks, buttons, etc. that will mount to our functions of the game. I think we want to pause this for now. To add input actions, we go to Project Settings and Input Map. Okay. Godot 4 comes with pre-existing input actions to enable them to see the UI underscore stands for user input, and you don't have to stick to the naming conventions, but I will because it looks neat. Okay, fair enough. You'll see Godot has already pre-configured the inputs to move a character left, right, up, and down. they've assigned the keyboard keys up, down, left, and up, down, left, and down. Up, down, left, and down. Up. Sorry, I think the author's made a bit of a typo. Up, down, left, and down. Up, right, left, and down, I'm supposing. Wait, this wasn't... Yeah, right, left, right, up, down. There we go. You can edit them by pressing on the pencil icon next to them, or even delete them. You can also assign other keys to this input by clicking on the plus icon next to it. I'm going to assign WASD keys to UI, up, down, blah, 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 blah. Okay. So we click plus. So say A physical. The tutorial does say the A physical, so I'm guessing this is right. So implementing WASD movement. UI down, yes. We'll come back to add our own input actions for attacking, consuming, interacting, sprinting, and so on. So less convoluted than Unity's input system, which is nice. Let's now add a script to the player so that we can move them around with these inputs. You can assign a script to any node, but remember that the script will only impact the node, and only that node's class objects will be callable, except, however, for root nodes. If you add a script to a root node, it will be able to impact and call the classes of all its child nodes. That node and only that node's class objects. So I'm guessing then that if it's declared as its own scene, then the scripts do work. But if I was to, I don't know, make a child of this animated sprite, and if I put a script on the animated sprite, it won't work. I mean, that's what the text seems to imply. Whatever. To assign a script to a node, select the node you want to add functionality to, which in our case is the root node, and in your scene doc, click the little scroll icon next to it. Save the script as player.gd underneath your scripts folder. Our root node, click the little scroll icon next to it. This thing? Attach a new or an existing script. I'm guessing this is it. Save the script as player.gd. Oh. Once a script node has a script attached to it, you'll see the scroll image appear next to it. So if you right click on your node, you can detach it and add a new one. Detach script. Yep. Click on the scroll to open your script, which will open the script workspace. At the top it says extends character body 2D. It says a lot more than that. How? Because this menu, that means all the properties and sub-functions of character body 2D will be callable from the script. So if you're unfamiliar with the scripting syntax of Godot, I recommend you go and read the documentation. From what I understand, it's like Python, except when it isn't. This func, for example, in Python it's def, but whatever. Let's look at the core functions you'll see throughout your GD script journey. You don't need to code this part. Init, which is called when the first object is first created. So that would be the equivalent of awake. It's called when the node and all its children have been added to the tree and are ready. So start, I suppose. It's called every frame, so that will be update. Physics processes fixed updates, and input is on input. Input's its own thing. You don't have to check for inputs in update. That's nice. I mean, I didn't do that anyway, but whatever. Now, to make our character move, we first need to define a movement speed variable. So, extend underneath this. Is there a comment? Ah, here we go. Control K, that comments it out. Same as Python. We need to define it so our extends, that's player.gd, extends by character body 2D. So we want at export of our speed equals 50. And the at export means that we can export this variable to be edited in the file, so it's like serialized field. Okay. So with your node selected, you can now change the speed value in the properties without having to assign it a constant value. This comes in helpful for when we create things like enemies and want to instance them multiple times in a scene and want them all to have different movement speeds. Next up, we will use our physics process delta function, which processes the character's movement physics constantly. In this function, we need to get the player's input direction. This input needs to be normalized for a smoother diagonal movement because our movement moves on a Cartesian plane level and once. Okay. One space up, down, left, right. Normalization will set the vector to the same length in any direction. So up, down, left, right. And does it? Well, it would. So if you're going like up and right, it'll normalize it to be, what was it? Root 2 left, root 2 up, or something like that. I don't know. Hang on. Okie dokie dokie. We'll then use the built-in move and collide movement function from Godot to enable the physics to move our player around whilst also enforcing collisions so they come to a stop when bouncing into other objects. And they've given a player.gd, so it's supposed to look like this. So I'm guessing this boilerplating was probably added in 4.1. I don't know. Okay. So we want func underscore physics process delta. So get player input. Should be playing move inputs, but we'll bar direction. Vector 2. Okay. So that's like saying vector 2 direction. In C#. Do they have Oh, anyways. Direction.x is input get action strength oh it has it in the suggestions for you. That's nice. UI right minus input get action strength UI left. Is there a duplicate line shortcut? There is not. Unfortunate. So we do the same for the y-axis. Yeah. If input's digital, normalize it for diagonal movements. Okay, so we do that root 2 thing. Okay, if there's no brackets for the if statement. If abs direction.x is equal to 1, and write that out, abs of direction.y also equals 1, colon, because it's an if statement, exactly like in Python, direction equals direction dot normalized. And there's brackets. There's none of this property malarkey that UNC has with their C# and where some stuff's methods, some stuff's fields, some stuff's properties. It's box. Yeah, it's hopefully consistent. So we apply movement now. I do like that it shows you tabs. It does show you indents. So, well, oh yes, the apply movement logic. So our movement var is speed. That field up there. By direction. By delta. I mean, if I was writing this, I'd call it delta t, but I'm not, so whatever. Moves our player around what's enforcing collisions. So then we'll copy paste this comment because I can't be asked to write it all out. Move and collide movement. Okay. Back to the tutorial. Full code now. Save it and let's go back to the main screen. Main scene even. Click the chain icon next to the plus icon, which will help us instance our player scene into our mode scene. Like so. Press F to focus on the player. Cannot see its children because it's treated as a complete object now rather than its individuals. Okay. Zoom out until you see this blue border. Don't know if you guys can see it on your screen, but it's a box about this size. This blue border is the border of the blue window is the border of the visible game screen or viewport, which in simple terms is the screen size you'll see when you run it. Our players will spawn in the top left corner, so we'll be able to see them properly. To run this, let's select them and drag them to a space closer to the middle or main edges. Ensure your select table is in all. Select tool is enabled for this, below main, which is the cursor. Okay, it's a bit unresponsive. If we were to run our game now, the player will be very small, that's because our game window is zoomed out pretty far from where our player is. That's because our viewport size is too big and our stretch mode needs to change. Let's go to Project Settings, Display, Window. And make the following changes. So viewport needs to be at 320, viewport height 180. Bloody hell, that's some resolution. That's before I was born resolution. Well, no, it's a viewport, not a resolution. Our character will be zoomed in now, and we can run our game by clicking on the play button or pressing F5. Oh God! Oh boy! I should probably have not put this on via Steam. Oh my God! Okay. Our character will resume now. I mean, we can run our game by clicking on the play button or pressing F5. Players move around when we enter WASD or D-pad, but without any animations. That's because we haven't assigned any animations for our input. But we'll... Excuse me. What was that? In the next part, when we focus on animations as an isolated topic. With our player character set up, we can move on to animations. You might be wondering about the world map as well as the camera setup for our character, but don't worry, we'll get everything in due time. Remember to save your game project, and I will see you in the next part. I mean, this Christine person will see the next part, but I suppose I will too. Loved it again. How do you have so much dedication to explaining such? Thanks, I do try to explain how and why the concepts are throughout, because there's no long-term advantage for learning something if you don't understand why it's doing things or how it works. That's good advice. Part 3. When was this published? 21st of June. So it's currently the 13th of September. So it would be a few months ago. Okay, yeah. You can tell by the yawning I'm not really in the mood for maths. Welcome back to our Dusty Trails tutorial series. If you missed the previous part, blah blah blah. By now, player's been set up and it moves around the map while we run the game. One problem though is that it moves around statically as no animations. We're going to focus on adding animations to the player so it can walk around and start coming to life. For each player we need the animations to move it up, down, left, right. For each of the directions we'll be setting up animations for idling, walking, attacking, damage and death. Since you have so many animations to tackle, I will take you through the first direction and then give you a table to complete the rest. In your player scene with your animated sprite 2D selected, player scene, please. Come on, don't have so many gajillion stuff running in the background. Well, relatively, I suppose. We already have an animated from walking downwards. Wait, here we go. Is it animation? No. Oh, it's animated sprite 2D. Here we go. I want to rename this to walk _down. Click the file icon to add a new animation and call this idle down. Just like before, let's select the add frames from sprite sheet option and navigate to the player's front sheet animation. So instead of animation, we call it idle down. Just like before, add frames from sprite sheets, the WAP button. Oh. Does it not save? Does it not save the sprite sheet settings? Or probably we're going to come up to that next. 4, not 45, you wazzock. So we'll want these. Oh, so you can click and drag. Add 6 frames. Change the FPS value to 3. Oh, so the FPS value is stored for each animation, right? Add a new third animation and call it attack down. For this one, you want to set the third row of animation frames. Waffle button. Same as always. You'd think that the editor would save the previous settings for when you want to go forward, but use the same thing, but oh god, it's all... select none, here we go. Boop. There we go. Change its FPS value to 7 and turn off looping. Oh, so it's white if it's not on and blue if it is on, okay. We only want this animation to fire off once and not continuously. Let's add a new animation and call it damage. New animation. Oh, hang on. We can bin that. This new animation, then we can double click it. Damage. Boom. Boom. Shake, shake. Shake the room. Change its FPS value to 1 and turn off looping. Finally, create a new animation, call it death. Add the final row of frames to this animation. Foregar, front. 14 and 5. There's got to be a way to save these as presets for a given image file. Change its FPS value to 10 and turn off looping. Now that we have our downward animations created as well as our death and damage animations, do you think you can handle adding the rest on your own? If not, reach out to me and blah 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 blah. Okay, so our animation window should... Whoa! Okay, I did not mean to click that. Sorry, what was it? Filippo Cepha? Cheffa? Oh, whatever. So, okay, so we want our animations to look like that at the end. So we want attack side. Oh, so it automatically sorts it. Okay, so attack side, player side sheet. Row 3, frames 1, 2, 8. New one called idle up. probably would want to change it to idle north, because yeah, that's just how I programmed things in Unity. Up backsheet.ping. Gotta be a way to save these. Where were we? Oh yes, idle up. Row 1, frames 1 to 6. Walk up. Which is... on. Idle up is free. Hang on. Let me search if there's a way to save the presets. Save the presets for, why is it? Oh, the sprite sheets, the sprite atlases. Okay, done a bit of a googling and it doesn't seem that you can do that, so bit of a pisser, but it is what it is, I suppose. Where are you? I made 2. It's alright. Attack up. Bottom button, back sheet. Okay, alright, idle side. By the way, I will be taking a hour or so break in 15 minutes or so. Yeah, a couple hours break, because I do need to run some errands, and then I'll be right back and then continue this tutorial until I'm well, I won't be going till midnight because I do have stuff to do tomorrow, but we'll get there when we get there. Walk side. Oh, before I forget. So idle side is free with looping. We'll want walk side now, and we've done attack side. Walk side. Boop. Boop. Boop 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 boop. Boop boop. No, walk, not attack. Okay, so attack down is 7, no loop. 7. F idle is 3 with loop. You can't select multiples because why would you? Walk down. Walking is 10 with loop. 10 no loop. 7 no loop. 7 no loop. 3 loop, 3 loop, 3 loop. 10 loop, 10 loop, 10 loop. Okay. Complete animations should look like that, and it looks exactly like that. I'll finish this part and then I'll take a couple hours break and then go for part, was it 4? Yeah, we're on part 3. So once our up animation display, if we press W or up, down, blah blah blah, left, right, blah blah. Let's open up our script by clicking on the scroll icon next to the player node. Because we have already implemented movements in our physics process, we can go and create a custom function on player animations based on player's direction. Function needs to take a vector 2, which is the floating point coordinates, and leaving a few existing code. Let's create our player animations function. Funcs physics process. Oh, so yeah, it's underneath the physics process. Func player underscore animations takes direction, which is a vector 2, and we'll pass it for now. Just like in Python. To determine the direction that the player is facing, we need to create 2 new variables. First variable, compare against 0. If it's not equal to 0, means it's moving. Let's create new variables on top of the script underneath our speed. Direction animation to be updated through game space. So var new direction equals vector 2 0 1. Okay, we're animation, and we just leave it at that. So this is sort of like dynamic. Yeah, it's Python. It's Python. Animations display function. So In a newly created function, we need to compare a new direction to 0 and assign the animation to it. If direction is not equal to 0, we are moving. Thus the walk animation should play. If it's equal to 0, we are still so play idle. How do we determine the animation? We do a long conditional check, or we create a new function that determines direction. And okay. Old code, so we put something underneath here. Function return the direction. Takes a vector 2 vector 2. It normalizes the direction vector to make sure it has length 1. Default return is side. Da, 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 da. Normalized. Yeah, we'll use the American spelling. Why not? Default return, okay. Is there a reason it's declared up here? Oh, whatever. If normalized direction dot y is greater than 0, return down. And we'll copy paste the rest of this long nested if statement. Keep going. Use space character for indentation instead of tab as used before in the file. Okay, so Python does, not Python, GDScript does care about that sort of thing. There we go. And finally, return default return. There's not really much reason why it's being declared here, it just is. In this function we check the values of our players' x and y coordinates, and based on that we return the animation suffix, which is the end of the word, up, down, side. We'll then append this suffix to the animation to play, which is walk or idle. Let's go back to our player animations and replace the 2D code with this functionality. I'm going to start copy pasting now. As the... yeah, this is going to be a problem. Okay, fine. It's still quicker than writing it out myself, I suppose. actually call this function in the function where we added our movement, which is the end of our physics process function. Player animations direction. Ah, here we go. If you run your game now, you'll see the player plays the idle animation if it's walk animation if it's moving, and he also changes direction. Save the scene. Excuse me. So if we play it now. Oh. Oh, I know what's wrong. Yeah, the Z-axis is sort of up the screen in Unity, and it's rather down the screen in Godot. So we just switch these two together, and it should work perfectly. Yeah, that's right. Fuck off, Steam. You might get an error if you run the screen. So run the scene. Oh. The local function. It's not showing on mine, but whatever. There's no animation with the name walk. So, okay. So it does not affect the game. It still plays 100%, but if policy is showing you where it goes down to fix it. In your player animations function, you create walk like that. This return direction can return up, down, side, but never just walk. It seems that that's the case. Walk is causing the error because there's no animation to run with that name. This also return directions for return an empty string. Of course, walk to pass into the pain function. This happens when the direction is not perfectly up, down, left, right, or when you press two buttons together. Okay. To fix this, we can replace our empty string with a predefined direction such as side instead of our return direction function. We also need to change our normalized value from 1 to 0 so that we can check the y components of our normalized direction. So it's just return direction. Our default return equals side direction dot normalized. Oh, it seems that the down, up, flip H false. I think they must have put the wrong code block up there. Oh, whatever. Now that when you press two buttons together, your side animation should play and the walk error should be fixed, which it was. Alright, let's also add the animation functionality for our player. So attacking and sprinting. These animations will require new input actions. So in your project settings on the input mat, let's add a new input. Call the first one UI sprint and the second one UI attack. Okie dokie. Input map. Add new action UI sprint. UI attack. Oh, come on. What the fucking hell? What the hell's going on now? Oh, don't tell me it's crashed. Please don't tell me it's crashed. Hang on. Give me a minute. Right, let's fix the problem. Yeah, for some reason this thing had sort of gone back behind Yeah, it just sort of like put itself behind the main Godot window, so that's why nothing was happening. Okay, so we'll do UI underscore attack. Assign the shift key to the UI sprint and the control key to the UI attack. Shift key to UI sprint. Yep. And control key into UI attack. You can also assign joystick keys if you want. Nope. We will have the sprinting input in our physics process because we will track our stamina values. Attacking input to our events because we want the input to be captured but not tracked during the game loop. You can either add inputs in Godot to its built-in input function, or you can add via the input singleton. You will use the input singleton, which we've already done so here. If you want the state of input action stored all throughout the game loop, because this is independent of any node or scene, for example, might want to use it in a scenario where you want to be able to press 2 buttons at once. The input function can capture inputs. Is action pressed and is action released? Plus, the input singleton captures inputs via the is action just pressed or is action just released. And there's a bit of a table. Okay. Has input been Okay. So I'm guessing this is sort of like in input system. You've got the Unity input system, you've got these started, performed, cancelled events, and I think this is sort of a matching. So is it pressed? Is the key down? Is the action released? Is it not being pushed down? So I'm guessing this is just the inverse of this. As the action just pressed, so has it been pressed this frame? Has it been released this frame? We about wanted to talk about half A presses and all that whatnot. Okay. Let's start with the code for our attack inputs. We want to play our other animations only if the player isn't attacking and vice versa. So play only the... well, whatever. Only play the attacking actions if it's attacking. And if it's not attacking, then you... okay. So to do this, we need to create a new variable which we'll use to check if the player is currently attacking or not. Oops. We in Python mode, not camel casing like we do in C#. It would help if I can spell correctly. False lowercase f. Now we can amend our physics process function to only play our return animations if the player is not attacking. So... we now need to call upon our built-in func input event. Let's add this underneath the physics process. Underscore physics process. No, not physics process, it's input. There we go. If event dot is underscore action underscore pressed UI attack is attacking is true. Var animation equals attack underscore plus return direction, new direction, dollar animate sprite 2D dot play animation. So this dollar animated sprite 2D, so I'm guessing the dollar means get component. You now realize if you run this and press Control 5 for your attack animation, you press the animation plays, but character does not return to its previous idle or walk animations. That's because the character is stuck on the last animation frame of the attack function. And to fix this, we need to use a signal to notify our game. Blah 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 blah. Okay. Oh, I think this is before. Oh no, no! It is stuck on there. This is because our character is stuck on last turn. Fix this, we need to use a signal to notify our game that's how the animation is finished playing, so we can set our is tagging value put back to false. To do this, we need to click on our animated sprite 2D node, and in the node panel, we need to hook up the animation finished signal to our player script. Double click on the signal. The signal. In the node panel, this thing, we need to hook up the animation finish signal. Double click on the signal and select the script to do so. Animation finished. Double click that. Connect the script. Oh, okay. Animation finished. Collect a signal to player. Receive a method. Connect. On animated sprite 2D animation finished, so it's created this thing here. We can now simply reset our is attacking variable back to false. Easy as you like. Now when you're running the game, they should return to the animations. Also want the player to stop moving when they're attacking, because currently they slide across the floor if you're holding control on any input. To do this, we can move our move and collide underneath the is attacking. So we're making it even more clunky. Nah, you're not making it clunky. I think it works the same way as Stardew Valley. Okay, so finally we can go ahead and add in our sprinting functionality for when the player holds down Shift. Since sprinting is just a movement, we can add the code for it in our physics process function, which handles our player's movement and physics, not animations. So yeah, add sprinting, and it's this that we have to put in. Physics process. So it's before the apply movement bit. Sprint. If input dot is action pressed UI sprint. Speed equals 100. Elif input dot is action just released. UI sprint. Speed equals 50. Then we apply the movement player and animations. Run the scene, you can see that the player is moving around the map with animations, and then you can sprint and attack. Your 4 code should look like this. With our player character setup, we can move on to animations. So the next part, we've created the map for our game, i.e. the world. As well as set up our player's camera. Remember to save your game project, and we'll see you in the next part. Troubleshooting. My player gets stuck between animation frames. If you realize it's up and down, don't worry, this is not your fault, it's the fault of the... which does not quickly enough to retest out. This goes to an animation frame backlog, which freezes the player. To fix this is quite simple. Add a few lines of code in our physics process delta function, which is where we'll simply check if our animation is finished playing and if we're not attacking. So, if not attacking and animated sprite 2D dot is playing, easy as you like. And that's the end of this part, so I'll see you in a few hours. Well, hopefully 1 hour. Gotta have tea, a load of other stuff. So yeah, I'll see you in part 2. Till then, I don't really have a sign off. Just good night, I suppose.